So in this video, we're going to go ahead and introduce how to solve a system of linear equations using the method of elimination. And again, these are going to be the steps that we use to use this method. And instead of going through all the steps, let me go ahead and give you the overall idea. What we're going to go ahead and do is multiply one of the equations so that we can eliminate one of the variables in the other equations. And then we're going to solve that resulting equation, and using that information, solve the linear system. Let's go ahead and look at an example of this. And we want to solve the following linear system. And the thing that we notice is that we have an x here and a negative x here. So to solve this linear system, we want to get rid of our x variable. So we're going to replace equation number 2 with equation 2 plus equation 1. Nothing happens to equation 1. It's still the same. This is going to be an x plus 2y is equal to a negative 1. And now equation number 2 becomes, let's see, x minus x, so our x's disappear. And then we'll get a 2y plus y, so we'll get plus 3y, and then we'll get a negative 1 plus 3. So this is equal to 2. Now what we see here is that in equation 2, we have 3y is equal to 2, so divide both sides by 3, and we see y is equal to 2 divided by 3. Equation 1, we still have the same. This is x plus 2y is equal to a negative 1. So now we know what our y is. Go ahead and plug that back into equation number 1. We'll get x plus 2 times 2 divided by 3 is equal to a negative 1. Simplifying equation 1, we see that x is going to be equal to 1 minus 4 divided by 3. And y is still equal to 2 divided by 3. And I almost made a mistake. Remember that there is a negative in front of this 1, so we have to be a little bit careful there. And we see that our x value is going to be equal to a negative 7 divided by 3, and our y value is equal to a 2 divided by 3. And this is our solution. Again, if we wanted to write this as a graph, what this is telling us is that we have two lines, maybe a line that looks like this, and maybe another line that looks like this, and they intersect only at one point, namely the point negative 7 divided by 3, comma 2 divided by 3. And so this is a consistent system with a unique solution, and so it's an independent solution. So let's look at one final example using elimination to solve it. And we want to solve the following system. So to solve this system, let's go ahead and write both of these equations in terms of y. So for equation number 1, let's subtract both sides by x, then divide by 3. So we'll get y is going to be equal to a negative 1 divided by 3x plus 3 here. And equation number 2 hasn't changed. We'll get y is a negative 1 divided by 3x minus 3. And now if we go ahead and replace equation number 2 with equation 2 minus equation 1, then we're going to get a y, equation number 1 hasn't changed. We'll see that y is going to be a negative 1 divided by 3x plus 3. But equation number 2, we're going to be given y minus y is 0 on the left-hand side. And then we'll get negative 1 divided by 3x minus a negative 1 divided by 3x. And so those terms cancel out. And then finally, we'll get a negative 3 minus a positive 3, which is a negative 6. So simplifying this, equation number 1 remains the same. But equation number 2 says 0 is equal to negative 6. And this is clearly not true. So what we have is an inconsistent system. And from this equation here, if we wanted to represent this as a graph, what we have is two parallel lines, one that's been shifted up by 3 units and one that's been shifted down by 3 units. And again, this is an inconsistent system, and it has no solution.